Circuits. We've already made a series circuit. That's where there is just one single loop, where you've got a light or a fan. And in my series circuit, my current just flows from my battery through the wires, through the light, and then back to the negative side into my battery, the negative side of the battery. So this is a single loop. This is a series circuit. Now what I want to be able to do is to make a more complicated circuit such that if I unplug a wire, one of my lights won't go off. So I'm going to use multiple lights for this activity. Okay, and I'm going to use these lights that have my green and red connectors on them, or yellow and black connectors. And part of why I want to do that is to make it a little bit easier so that we can trace the positive and negatives. Okay, so these are two yellow and green LED lights. Okay. So again, these lights that I've picked up, they managed to have the black to be positive and the other color, the black to be positive and the other color to be negatives. So we have to keep that in mind. So I've got my battery set up. So let's plug my first light in. Okay, and let's just make sure that we're getting everything wired up right. So my yellow is going to be positive, and in this case this side is going to be negative. And maybe I have this one where it's the opposite. Let me see here. Oh, look at that. I wired it in wrong. Alright, so let me have it wired up. There we go. Alright, so I've now got my little yellow light is on, and the current's flowing out of my red, it's flowing into my black, which in this case is positive. It goes through my LED, back to the negative wire, back into the negative side of the battery. Okay. So now I want to be able to hook another wire in such that if I unplug a wire in the light system, that my lights will stay on. So there's a couple of ways to do this. So let's think about this as a loop. So right now I have a very simple loop, right? Is I have a light going from, or a current going from red to my light back into my battery. So it's just a very simple loop. To make a parallel circuit, we need that second light to be on a second loop. So here's what I'm going to do. Is we can very easily put in the light on the other side of this circuit. Okay, so now I've got my two lights on. Now the current flows in, it reaches to this point. Now it's going to split. Part of the current's going to go through this light, part of the current's going to go to light number 2. Okay, it's going to flow back through my wire, get back to my negative, and flow back in. Okay, so that means that if I unplug one of the light bulbs, my other one's going to stay on, because now my current is going to flow through each of the bulbs. If I can keep my wires plugged in. There we go. Alright, so now I've got red, right? It's positive, it's going to flow through, it's going to flow out through my light, back to the negative. This light is off, but this one is on, and all I did was simply unplug one wire. Okay, so you can basically add any number of lights in this regard, because each one of these is making a separate loop. Right, so if I put in my green one, and I'm going to put him in, and I'm just going to attach him right into the same loop. Now he's on. Now I've got 3 lights in my circuit. current flows in, it hits this point. I've got 3 wires leaving this point. Okay, right? Part of the current flows to this bulb. The other current gets split and it flows to these 2 bulbs. And assuming that these bulbs are all the same, the current's going to be split equally 3 ways. Okay. Then the current flows through each of my bulbs. It gets back to my negative, and then the whole current again goes back to my battery. And I can just keep doing this over and over and over again. Right. I can just keep adding light bulbs in until I kind of overwhelm my battery, or I start getting bad connections, one of the two. And it just gets hard to connect the lights in. Okay, so what I'm going to do to make this one work, to get my 4 in, I'm going to do a little clip. And you can use scissors to do this at home if you don't have fancy wire strippers. You just need to oftentimes get a little bit more of the wire exposed so you can twist them all together so they'll stay in our little terminal block. So now notice I've got more wire exposed, and I'm going to twist all of my black ones together so they're going to make one end. Okay, and I'm going to stick them all in so now they stay. Alright, and so now I've got 4 loops. Right, current flows out of my battery, it goes into this point right here where the red goes in, and I've got 3 wires going out to these 3 lights, another one going out to this light. The current is split 4 ways, and what's going to keep happening is as I add more and more and more lights, I'm going to keep draining more and more current. Okay, because one of the nice things that happens in a parallel circuit, and it's also a negative thing, is that as you add more load or more lights in a parallel circuit, the resistance of that circuit actually goes down. This is part of what happens when you blow your breaker in your house, is that you've plugged in too many things and it draws too much current, and you've got a breaker which is basically the equivalent of turning off the current, and so that kills everything that is attached to the circuit until you have to go reset it. And then once you've got it reset, then you are good to go. So that's why you can't plug in an infinite number of things into a single outlet, because usually there's a max on the current. Because if you get too much current, what happens is, remember, electricity is nothing more than moving electrons. As those electrons move, they're causing friction, and it's causing the wires to get warm. And that's usually what causes electrical fires, is the wire itself has gone bad, and that the wire heats up and it catches on fire because you're sending too much current through it, because again, it's just friction. And there is our parallel circuit. Right? These are very common. Your entire house is wired up in a parallel circuit type of arrangement.